Go.
Assalamualaikum. I am Syed Hussein.
And my name is Salahuddin Arif bin Yusufzaki.
My name is Muhammad Hafizuddin bin Yahya.
My name is Muhammad Agam bin Abdul Aziz.
We would like to present about the properties of discrete uniform, negative binomial, and standard normal.
Okay, I will continue our presentation in discrete uniform. First is about probability density function. Fs is equal to 1 over n, and for s equal to 1, 2, so on until number n. Okay, for moment generating function, the function is e to the power of alpha t minus e to the power of beta plus 1 t over n 1 minus e to the power of t. Continue into mean alpha plus beta over 2. Continue to variance n to the power of 2 minus 1 over 12. For scenario, first example for scenario is success in an examination. Second is failure of engine in an aircraft. Third is picking a particular suit from a standard deck of playing card.
Okay, hello. Moving on to the second distribution, which is negative binomial. So, okay, this is the probability density function. As you can see that the PDF for negative binomial is C R plus x minus 1 x times by PR 1 minus p to the power of x, for which x is applicable for non-negative integers only. So moving on to the MGF, moment generating function. So the formula is 1 minus p to the power of 1 minus p over 1 minus p e to the power of t, all of that to the power of r, for t is smaller than negative log p. So moving on to the mean, which is PR over 1 minus p. The variance is PR 1 minus p to the power of 2. So lastly, we are going to explain a bit about scenarios. Here we would like to highlight about 3 scenarios, which is the first is returning again to the coin toss example. Assume that you hold the number of success fixed at a given number and estimate the number of tries you will have before you reach a specified number of successes. So the resulting distribution is called the negative binomial, and it is very closely resembles the Poisson. In fact, the negative binomial distribution converges on the Poisson distribution, but will be more skewed to the right with positive values than the Poisson distribution with similar parameters. So moving on to the next scenario. An oil company conducts a geological study that indicates that an exploratory oil well should have a 20% chance of striking oil. What is the probability that the first strike comes on the third well drill? So, to find the requested probability, we need to find probability of x is equal to 3. Note that x is technically a geometric random variable. Since we are only looking for one success, since a geometric random variable is just a special case of a negative binomial random variable, we will try to find the probability using the negative binomial P and F. So in this case, P is equal to 0.2. The probability of failure, which is 1 minus P, is 0.8, and R is equal to 1 and X is equal to 3. So if you just substitute all the values inside the formula, you will get the final answer is 0.128. So moving on to the next scenario. A hospital has received a total of 17 people with a rare disease in the last month. The disease has a long incubation period. There have been no new admissions for this disease for a fair number of days. The hospital knows that people infected with this problem have a 65% chance of showing symptoms and thus turning up at the hospital. They are worried about how many people they are infected in the outbreak who have not turned up in hospital and may therefore infect others. So the total number infected would be 17 plus negative binomial, 70 plus 1, 65%.
Assalamualaikum. So we will continue to standard normal distribution. As we know, standard normal is subtopic for normal distribution with the parameter of mu and variance. So I will continue with PDF. PDF for standard normal is data x equal to 1 over square root of 2 pi e power of negative half x squared. So this is the MGF, that is moment generation function. which is the final answer is e to the power half t squared. Like I said before, the parameter for standard normal is mu and variance. So standard normal is mu equal to 0 and variance equal to 1. As we know, standard normal can be used in everyday life. So this is the scenario that we choose to explain to you. So first one is people want to estimate the arrival time of the train. You can use the standard normal distribution. Second is RF that want to know if there are any relationship length and the weight of this body. And last one is one day at the convenience store, a lot of foreigners making purchase, and the owner want to estimate in that day how many foreigners make purchase of their souvenir. Okay, that's all. Thank you. Hope to see you again.